while introducing these functions of trigonometry, which I use for the resolution of these things, and particularly I said that this is ax is equal to a cos of theta, or resolution in the x direction is equal to a cos theta. Allow me to talk a little bit about this. Theta and its trigonometrical associates. So let us go back and let us see as to what was theta. The theta was defined as arc upon radius. Arc is a length and so is the radius. So one length divided by another length, this gives us a dimensionless quantity, and it is simply a number which we express in degrees, as also we express in radians. We'll have occasion to understand that maybe today, maybe tomorrow, maybe after that. Now, the trigonometrical relationships that we had, I had first of all, I had the sine theta as a function of theta, and I have to extend this in the other direction, in the sense that a negative angle is also incorporated. Now, the value that we have, I have the maximum value of 1 and the value which can go ahead, and I can say that the limit value is sine theta is equal to -1. Similarly for the cos theta, that we'll have, and if theta is taken in this axis is taken in terms of, say, pi by 2, I prefer to write it as not pi but 2 pi by 2, because pi by 2 is the unit, 3 pi by 2, 4 pi by 2, which is just equal to 2 pi, and that means the circle has come around to the same point under consideration. If we do so, then as we know, and most of us do, that the value of sine of theta when theta is equal to 0 is equal to 0, and the value of sine theta when theta is equal to 90 degrees r pi by 2 radians is equal to 1. So what I will get is what is called a sine curve, and that value becomes equal to 0 when the value of theta becomes equal to pi or 2 pi by 2. And similarly, I can extend it and then it will repeat itself like this as the value of theta is increased. What it means by increasing the value of theta beyond 4 pi by 2, because in the reference circle that we have, if we start from, this is the reference line, and then this angle is theta, and if I take it around from here, this point, anti-clockwise to the same point back again, that the total angle which has elapsed is equal to 2 pi or 4 times pi by 2. If it elapses again I'm sorry, and therefore an angle which is obtained here, which is equal to 2 pi plus theta, the values and all the ratios etc. will remain the same. Again, if we go ahead and then come back to this point, it is 4 pi, okay, and plus theta, and the same angle is again obtained, etc., etc. Now if I go in the negative direction of theta, and I just brought 1, and this is 2 pi by 2, of course this is minus, and this is minus pi by 2, and what we will find is that the curve will go something like this. Now the curve is not symmetrical about this sine theta axis. It is not symmetrical. So I can say from here, as also I will tell you how, that sine of minus theta is equal to minus times sine of theta. But if I take and plot the cosine curve, for example, that will go like this. It starts at a maximum value of 1, and thereafter as the value goes to pi by 2, then the value of cos of theta becomes equal to 0, and then again this going to minus 1, and my hands are sort of trembling, so it goes like this. But if we take, so this red curve is for cos theta, and if we complete it, it will go something like this. So I hope you understand. Now this curve, the right hand side of this and the left hand side of this, they are mirror images. So because they are mirror images, therefore we can say that cos of minus theta is equal to cos of theta. So what has to be understood? What has to be grabbed mentally? So cosine of minus theta is equal to cos of theta, but sine of minus theta is equal to minus sine of theta. So this function becomes symmetric, and this is, you can say, asymmetric or non-symmetric or whatever you want to say. So that is what it means, that the two functions are a bit different from each other. Now I want to go back, because everything is not possible for me to do here. My purpose is not to teach you trigonometry, but I'll just give you a relation of trigonometry, which is, say, sine of the sum of two angles A plus B. This we expand as sine A cos B, sine A cos B plus cos A sine B. Cos A sine B. When I was a young boy, we used to call it sine A cos B plus plus sine B cos A. So anyway, it doesn't matter at all. So we can see that the sum of the two angles, and if you can see that I have this sine of A plus B, and this I can write is A plus minus B. Okay, if I write it like this, that is, we are going to have a sine of A minus B, then we get this as, I can write sine of A cos of minus B plus cos of A sine of minus B. What I'm sharing with you is something interesting. I said that cos of minus theta is equal to cos of theta, so cos of minus B will become equal to cos of B. So I can write this formula in the familiar form, that sine A cos B, and here I'll get, because sine of minus B is equal to minus sine B, so minus cos A sine B. So I can write this total formula, and which we will remember in short. In sine A plus B, if I take this as minus, then what is going to happen ultimately is that this plus sign is going to change to minus sign, and I have sine of A minus B is equal to sine A cos B minus cos A sine B. Also, from here itself, I take advantage of, it is cos A sine B. So I take advantage and put the value of B equal to value of A. And if I say that sine of, therefore, sine of A plus A is equal to, like before, sine A cos A plus cos A sine A, the product is the same, so this becomes equal to 2 times sine A cos B. So doing that, a biology student who has forgotten the trigonometric exercises is able to say that sine of 2A is equal to 2 sine A cos B. Sine of 2A will remember as equal to 2 times sine A. Aha! I must be an idiot. I must remove this B and write A. So this is 2 sine A cos A. So sine of 2A we are able to do like this, and similarly, shall you allow me to write the other equation of cosine A plus B. Cosine A plus B is obtained, so I'll just rub it off and just introduce that using the same thing. Okay, I'll just say that we can write cos of A plus another angle B. Remember, A and B both are dimensionless quantities, so that they are just numbers. Cos of A plus B is equal to cos A cos B minus sine A sine B. So the reminder that should go to our brains is that in the case of sine of a plus b, here the relation is, here there is a plus sign, but in the case of cos a plus b, here there is a minus sign, and I can write that cos a minus b here for a minus b. Similarly, I can write cos of a cos of minus b, and here it will be minus sine of a sine of minus b. So this sine of minus b is equal to minus sine b, and therefore this becomes a plus sign. So this is equal to, and this cos of minus b is equal to cos of b from here. So applying that, I'll get that if I have this cos of a minus b, then this will be cos a cos of b plus sine a sine b. Okay, so look here. In the first instance, I had for sine of a minus b, I had sine a cos b minus cos a sine b. But now it is cos a cos b plus sine a sine b. And if I put in this relation b is equal to a, then I get cos of a plus a, which is equal to cos of a plus a is equal to cos of 2a. Cos of 2a is equal to, finally I'll eat up a step, cos square a minus sine square of a. So this is another relation that we'll get, and now allow me to use this relation along with the identity that we had, and the identity is that sine square theta plus cos square theta is equal to 1, or cos square of a plus any angle sine square of a is equal to 1. Okay, so what happens? Now this is the relation and identity which I can use in two more ways. I can say that cos square of a will be equal to 1 minus sine square of a, and cos sine. So this sine square of a will be equal to 1 minus cos square of a, and therefore if I submit it here in the cos 2a thing, cos square of a is equal to 1 minus sine square of a, so I'll get cos of 2a is equal to 1 minus 2 sine square of a, and cos of 2a is also equal to, using this relation 1 minus cos square of a, I can write this as 2 cos square of a, 2 cos square of a minus 1. Now you may just say that, why am I teaching all these things? Why am I looking into the small tits and bits of this? So for example, I am going to tell you the usefulness of these relations that I've derived here, that from this relation, the first relation over here, if I am allowed, I can write that sine A will turn out to be equal to 1 minus cos of 2A divided by 2. What? Under root. And cos of A, I can again obtain from this relation cos of A is equal to 1 plus cos 2A divided by 2 under root. So these are the sum of the results which should be here, which we should be able to recall. By small scribbling, these values can be obtained. Now you can see, for example, why is it that if there is a sine or cosine wave and the energy of the wave is proportional to the square of sine or square of cosine, in that case you can see that the frequency which was omega that we were using there will be occasion to come to that frequency actually doubles if the energy relations or power relations are taken into consideration. Now, with this, I sum up some of the results that we will need and straight away go to position and displacement vectors, scalar and vector quantities, representation of vector quantities, etc., equal and unequal vectors, zero vector, collinear vectors, coplanar vectors in the same plane, and then vector addition and subtraction using the tail to head method and also the law of parallelogram of forces. These laws, some triangle laws of forces, polygon laws of forces, etc., etc. So now, to close it now, I would like to ask you a very simple question to ponder. And that simple question is that suppose I have two vectors A plus B is equal to a vector C. Okay? It's very easy to write a mathematical equation, representative equation like this, but to understand what it means, there is something which is not defined by my friends, by my mathematics friends also, that there is an unwritten law about this vector addition and subtraction. What is there? And that law is that the two vectors A and B should belong to the same family of vectors. For example, if I say that this is a vector, say velocity plus acceleration. So does it carry any meaning? It does not carry a meaning because the vector over here is a velocity vector and the vector over here is an acceleration vector. We cannot add them together. We cannot put them together even if they are in one plane simply because they belong to the different species. So these vectors should belong to the same family. They may be parallel, they may be anti-parallel, they may be having any values. So when you prepare yourself for the next lecture where I talk to you about the vector and scalar quantities, and I will not talk much about vector and scalar quantities. I just ask you to read it anywhere, Google it out, or whatever way. What are the scalars? The scalars are the quantities we do not have. They are physical quantities which do not have any direction specified for them. They have only magnitude, and we can say that their magnitude is always positive. So that's all for today. Okay, thank you very much. Hope you enjoyed. And these very small things about the sine theta and cosine theta, particularly this cos of minus theta is equal to cos theta, and cos of minus theta, sine of minus theta is equal to minus sine theta, a symmetric function and an asymmetric function. These things must be. This is for you to look into the things, to put in or here, okay, from this side or that side, whatever, and be prepared for other things, because what is going to follow is a set of things which you will not get from the books, which you get from your inner instincts, inner questioning instinct, and you'll find the answer yourself. Interesting, and we now indulge into these things and then take up some of the problems, the due course of time. Maybe in the 17th lecture or 18th lecture, I don't know. I'll prepare that. I prepare each and every lecture all my life. On the day I have to deliver that. Then the papers, I tear them off and do it again when need be. So thank you very much for being with me, and if you have any questions, you're most welcome to ask in the comments column, so that I may be able to answer you if you have any difficulties. So here, one thing which I have just put over here, if suppose this were with capital T by 4, so here I write 2 into capital T by 4, 3 into capital T by 4, so that equal intervals are vivid to us. Similarly, other things. Bye for now. Thank you.